We'll discuss about Chinese and Indian mathematics. I understand that many of you will not be able to join this afternoon's online session. But anyway, the video is recorded so you can just view it when your internet connection will resume or when you have the data to view the video. So anyway, I have uploaded the PDF file in Lens so you can go over, but the rest of the solutions to some of the problems are not indicated, or should I say reflected, in that PDF file. So I could anyway, right after the session, I could send our notes, okay, PDF file of the solutions of some of the problems in that PDF file. So this afternoon, we will discuss some of the theorems, some of the contributions of the Chinese and the Indians in the field of mathematics. We begin with Chinese math. Okay, so the art of calculation or mathematics for the Chinese is considered to be the art of calculation, or Suwan Chu. And just like your Egyptian math, it's also practical. Okay, it's problem-based. So it sprang out of practical reasons. So if you could remember, the Egyptian math, geometry sprang out of practical reason. Constant flooding of the Nile River. So they have to find ways and means by which they could be updated of the dimension of their lot, mga lote nila. Constantly flooded kasi siya. So, ganun din sa Chinese mathematics. It's problem-based. It's motivated by problems of the calendar, trade, land measurement, architecture, government records, and taxes. Chinese mathematics serve the needs of the society because the geographic location of China, medyo isolated siya from the outer world. So the Chinese needed controlling the flood-prone Yangtze River, the Yellow River. So mathematics helped solve the problem of safe environment in a water-dependent society. So civil service needed to be, or should I say, people in the civil service or public service have to have excellent skills in mathematics in order to work things out. Okay, like nga sabi nga natin, taxation, calculations needed particularly for trade purposes. Yan, trade, land measurement, yan, architecture, government records, and taxes. Next, now the first true evidence of mathematical activity in China can be found in numeration symbols on shells ng mga turtle and flat cattle bones. So, commonly called oracle bones. So, in your reading, you may have encountered oracle bones, referring to tortoise shells or flat cattle bones. And it dates back to the Shang Dynasty, which is during the 14th century BC. So your oracle bones are also called dragon bones. They were shoulder blades of oxen or plastron of turtles. Okay, next, numerical writings contain both tally and code symbols which are based on a decimal system. Decimal base 10. Okay, most of the symbols became words and recognizable Chinese script. They also make use of the oracle bones to tell the future, fortune telling. And this art is called scapula, from the word scapula, scapulimancy. Okay, for fortune telling, that's for the Chinese. You know, Chinese are known for their feng shui, yes? Next, another feature of Chinese mathematics is this. Okay, employed a positional value system, and this proved that the Chinese were one of the first civilizations to understand and efficiently use a decimal numeration system. Which among the ancient mathematicians or groups of people have made use of base 10 also? If you could remember, can you recall? Decimal, yung base 10. Babylonian is base 60, right? Sexagesimal sila. Can you recall? Which ancient group of people made use of a decimal numeration system also? O recall nyo nga, base 10. Yung mga may iba't iba silang mga symbol for 10. May symbol for 1, may symbol for 10, may symbol for 100, may symbol for 1,000, may symbol sila na parang goddess whose arms are raised. Egyptian? Okay, Egyptian, you're right. So J. Mark said Egyptian, yes. So aside from the Egyptian, Chinese mathematics made use of decimal numeration system. Next, okay, Chinese calendar represents one of the longest unbroken sequence of time measurement in history. So calendar, Chinese calendars. The need to provide a safe environment in a water-dependent society and to control, yan, practical. It's problem-based. So mainly to solve the problem of constant flooding. Flood-prone kasi yung China because of the presence of yan, the Yangtze and the Yellow rivers. Okay, and the problem were solved using science and mathematics, including yan, construction of canals and dams. And the creation of the magic squares. Are you familiar with the magic square? Have you seen a magic square or have you worked with a magic square in the past? Anyone who could describe a magic square? Those of you who have encountered magic squares in the past, will you please describe it? Ano yung magic square? So look at this. Egyptian hieroglyphics, correct. Joselle said Egyptian hieroglyphics, correct. Base 10, that's decimal system. Okay? So I'm constantly checking on my screen also because some students are sending their responses. Medyo late nga lang because of the lag, because of the connection. Okay, so going back to magic squares, anyone who was able to work with the magic square in the past? So anybody of you who could describe what a magic square is? Okay, so if none, then I want you to look into this. Let me highlight ito. What makes this a special? Okay, what makes this a special square or a magic square? Now, if you look into the sum of the numbers diagonally, okay, sum of the numbers diagonally, 6 plus 5, 11 plus 4, 15. Okay, what about the other diagonal? 8 plus 5, 13 plus 2 is 15. Okay, now horizontally, if you get the sum of the numbers horizontally, 4 plus 9, okay, 13 plus 2, 15. 3 plus 5, 8 plus 7, 15. 8 plus 1, 9 plus 6, 15. Okay, something like when you add from diagonal, vertical, and even horizontal, the sums are equal. Okay, so that's according to J. Mark. Okay, so that's a magic square. The sum of the numbers horizontally, vertically, diagonally are equal. So in this case, okay, the sum of the numbers vertical, horizontal, diagonal are all equal to 15, and that is a magic square, or in the Chinese, they call it the Lo-Shu square. Okay, the Lo-Shu square or the magic square. Do you know how to construct a magic square? Okay, so let's see how a magic square is constructed. Okay, or prior to that, let's look into this first. Ito daw is the pattern of dots you saw on the turtle's shell. So, if you notice, compare it to the numbers that appeared in the Lo-Shu square. Let's go back to the Lo-Shu square. The Lo-Shu square, the first horizontal, okay, or the row rather, the first row consists of the numbers 4, 9, and 2. Okay? Sabi natin kanina, early records of Chinese mathematics are found on turtle shells. O, ito daw. On one turtle shell, the following dots, okay, pattern of dots were discovered. Here, number of dots, if we count the number of dots, ito 9, okay? 4. 4, and here we have 2, 4, 6, 8, 9. Here we have 2 dots. Here we have 3 dots. At the middle, we have 5 dots. 2, 4, 6, 7 dots. 1 dot, 8 dots, and 6 dots. So that if we compare these numbers to the entries on the Loshu square, yeah, they are exactly the numbers, yes, or the entries on the Loshu square. 4, 9, 2, 3, 5, 7, 8, 1, 6. 4, 3, 8, okay, vertically. So for vertical, the entries along the first column rather, or vertical, okay, vertical entries are 4, 3, 8, that's 15, 5, 9, 5, 9, 5, 1, 15, and 2, 7, 6 is also 15. Okay, next. So can you try this magic square? Try this magic square called the Loshu square. 4 plus 3 plus 8, okay, 4 plus 3 plus 8, this is equal to, okay, 15, yes? So what should this be? This must be 1, okay? So if we complete the square, okay, the missing entries will be 1 here, okay? And what about, 2 rather. This is supposed to be 2, then this is, what should this be? 5 to make it 15, because the first vertical row, or should I say the first column, has, or the sum of the numbers along the first column is equal to 15. And so it has to be 15 all throughout. So this one is 15. Okay, and what should this be? It should be, what should this be? It should be 6. Okay, 2, 5, 6. So that when we add now, vertically the sum is 15. Horizontally, we have 15, 15, and then 15. And you check also vertically, diagonally, I should say, 8 plus 5 plus 2 is 15. 4 plus 5, 9 plus 6 is 15. Okay, so this is an example of a magic square. Now, is this the only arrangement possible for a magic square? Now, suppose I ask you to come up with your own magic square. Can you come up with your own magic square out of this? So this one is a 3 by 3. Okay, it's a 3 by 3 or 3 by 3 magic square. Can you fill this out without referring to the numbers here? I don't like this arrangement. Can you make your own arrangement? Or do you know of a technique by which we can come up with our own magic square from here? Can we start with any number? Should we always begin with 1? Now, there is a technique to coming up with your own magic square beginning with any number. Okay, but if you like 1, it's alright. But this is a rule. If you start, okay, wag muna tayo magbigay ng number. Let me just use X muna to mean any number. Because you could begin, in fact, with any number. So, for instance, you started along this box. The motion is, from here, move top left. Top left or top right? This way. Okay, from here, you have to move to the next cell. Okay, in that direction. Again, and if you start from here, move again top, pretend that there is a box here. Then drop this down. Okay, whatever that number is, write that number here. and then move top left once again. Okay, so once more, if I start from here, then move top left, and then move this way once again, and then next. Okay, but since this is empty, drop down. Okay, and then if you start from here, move left. Now, assume that there is a box here. Okay, but since this is empty or this is not part of the cell, we have to write that number here. Then continue the process from here, top. Okay, since this is not part of the cell, drop that down here. Okay, so let's illustrate. Gawa tayo ng sample. Okay, so hindi necessarily 1 for as long as the numbers are consecutive. So for example, I'll make a 3 by 3 magic square. 3 by 3 muna tayo because you can have sizes of 4 by 4, 5 by 5. So kung 3 by 3 tayo, let's say I'll start with 1. Okay, so 1, sabi natin, top. Okay, from here, move top. Okay, however, this is already outside the box or it's not part of the cells anymore, so we have to drop it down here. Okay, drop it down. What's the next number to 1 is, it's 2. Okay, I hope you can follow. And then from here, move, okay, in this direction once again. Pag ganun yan, pataas lagi. Since this is empty, okay, empty, or should I say it's not part of the cell, then we have to drop, or should I say, move this to the first cell along that row. Okay, horizontally. So, 3 must be written here. Next, once more, top. Okay, 3, move it. Okay, but this is already occupied. So the rule is, if it is already occupied, write it below, okay, the previous number. So 3, move this down, then this is where the next number should be written. Why? Because this cell is already occupied, so we drop it to the cell below the previous number. And then continue moving in that direction, move up. Okay, this is 5. Okay, I'm going to write 5 here now. And then move up once again, so I'm going to write 6 here. Next, so still continuing in that motion, then 7 must be here. Okay, 7 must be here if this cell is part of, okay, of, or should I say, if there is a box, or assuming that there is a box here, 7 should be here. However, okay, it's not part of the cell, so just like what we did to 4, drop this down. So, ilagay natin siya sa baba ng, okay, ng 6. So, 7 doon. Then, continue moving top left. 8 dapat dito, pero hindi parte ito. So, we have to move, should I say, write 8 along the first cell, okay, on the first cell of the first row. Okay, first cell, so 8 dito. Then continue moving in that direction, 9 dapat dito. So drop it down, 9. So, enlarge natin. 2, 4, 6. So let's copy the numbers in their particular cells. Have here 8, 1, 6. 3, 5, 7, 4, 9, and 2. Let's check whether this is a magic square or not. Otherwise, we have to check on the position of the numbers. So, getting the sum, 8 plus 3 plus 4, correct. This is 15. Okay? So, the sum of the first row or first column rather is 15. Next, 1 plus 5, 6 plus 9 is also 15. Next, we have 6 plus 7 plus 2 is also 15. Okay? How about horizontally? Okay, 8 plus 1 plus 6 is also 15. Next, 3 plus 5 plus 7 is also 15. Okay, 15. And then 4. Then 4 plus 9 plus 1 is also equal to 15. Now, diagonally, we check on the sum diagonally. This is 9 plus 6 is equal to 15. And the other diagonal is 8 plus 5, 13 plus 2 is also equal to 15. So the sum of the numbers diagonally, vertically, and horizontally are all equal to 15. So this is an example of a magic square. Okay? So it's a magic square. Now suppose I start with a number other than 1. Pwede lang ba yun? Let's see. Let's see whether the technique works even if we begin with a number other than 1. So let's say, let me 2, 4. Sige pa, tingnan nyo kung mag-follow nyo yung technique. Okay, let's say 5. Let's begin with 5. I want to start with 5. Just the same, dito muna tayo mag-start. Okay, so 5. Okay, in this direction, however, this is not part of the cell, so drop it down, dito siya. Okay, again, dito dapat, kaso halo yan. Okay, it's not part of the cell, so drop this down to the first, or to the last rather, to the last cell along this column. Next, okay, we continue filling out the cells in this direction. However, ito, bakante, hindi parte. So, what shall we do? Write the number on the first cell of the second row. Okay, first cell of the second row. So, what should this number be? 7. Okay, 7. Next, if we continue that in that manner, in that position, or in that motion rather, the next number must be written on this cell. Okay? The next number must be written on this cell. However, this cell is already occupied. So, ano yung sabi ko kanina? If it's already occupied, okay, write it below. Okay? Write it below the previous number. Okay? So, this goes back to the cell just below the previous number. So, I'm going to write here 8. Okay? Next, we continue in that direction, 9. Okay? Continue in that direction, 10. Next, okay? 10, and then, saan ba punta si 10? Dito dapat, di ba? Okay? Pero wala. So, balik tayo pababa. Okay? Pababa sa baba mismo ni 10. So, where am I going to write 11? Just below 10. Then, if you continue, so 11, pero hindi ito parte. So, where shall I write 12? The first cell along that row. Okay? So, 12 dito. Next. Okay? Continue the motion. Dito yan dapat. Pero saan dapat ilalagay? This is empty, or should I say, this is not part of the cell. So, bring it down. Okay? What should this number be? Okay? The next number to 12 is 13. And that's it. Okay, so first let's check whether the sums vertically and horizontally are equal. Okay, get the sum of 12 and 7, that's 19. Okay, plus 8 is 27. Tama? Next, okay, how about 5, 9, 13? 5 plus 9, 14. 14 plus 13 is 27. Next, 21 plus 6 is 28. Okay? 27. How about diagonally? So, diagonally, okay, this is 15 plus 12 is also 20, 27. Okay, vertically is also 27, 27, 27, and then the other diagonal, 8 plus 9 plus 10 is also 27. Okay, so 27. Other questions here? Okay, so you may begin with any number. Okay, begin with any number. So this is an example of a 3 by 3 magic square. Okay, so that's just one technique. And there are other techniques that you may apply, okay? Or you can make use of. Okay, so you're right. Magic square, 27. So here are a lot of solutions. Madami nga eh. So these are the possible solutions to your 3 by 3 square using the numbers 1 to 9. Okay? Let's see if this employed our, tingnan nyo to. I want you to look into the last here. Okay, applying the technique. So if you start with 1 here, where should we go? This direction, yes? However, this isn't part of the cell anymore, so you have to write the next number along the first cell of the first row. Okay, next, continue moving. 3 dapat nasa taas, but this is not part of the table anymore, so drop it down. There you have 3. Okay, 4. Iba naman to the right naman siya. Okay, so right before naman siya. It's not right below. So it's a different technique. So right before siya. Then 5, 6, 7, right before. Ito kanina, right below. Ito to the right of, or to the left rather, okay, of the number. So there are several techniques. Challenge, can you come up with your own 4 by 4 made magic square? So the first examples were all 3 by 3. The first, how many examples did we have? 1, 2. Okay, 1, 2. Okay, these are 3 by 3 magic squares. How about a 4 by 4 magic square? What about a 4 by 4 magic square? Okay, what numbers shall I fill this out? Okay, let's say I'll have here, I could fill this out with the numbers 30. Okay, let me use another ink. Okay, 30, pwedeng 30 yan, 1, 12, 7, 11, 8, 29, 2, 5, 4. If you get the sum 30 plus, this is sum of 50, yes? The sum of the first column, 30, okay, this is 50. So 1, 8, 10, 31. Is it 50 also? Yeah, 50 din to. And then 12, 29, 3, 6. 12 plus, okay, tama, 50 din yan. And then 7, 2, 32, 9. Okay? So 41 plus 9 is 50. How about horizontally? 30 plus 20, 50. 19, 48, 50. 15 plus 35, 50. Okay, 4, 31, 35 plus 15, 50. And diagonally, 30 plus 8, sorry. Erase. 8, 8. 38, okay. 41, 50. Tama. And then the other diagonal, 14, Okay? Plus 29. Okay, so 50 lahat. 50 lahat. Now, if you look into a square, considering a 2 by 2 cell, 2 by 2, what's the sum? 30 plus 1, 31, 39, plus 11, 50 din siya. How about this? Let's use a different color to distinguish it from the previous. Ito, 8 plus 1, okay, plus 12 plus 29, di ba? 50 rin. Okay, in like manner, if you consider this, okay, 2 by 2 cells here, 10 plus 3, 13, okay, 19 plus 31, 50 din siya. Ito rin. Okay, 5 plus 4, 10, okay, 5 plus 10, that's 15, and then 4 plus 3, 50 rin. Okay, 50 din siya. Okay, how about this? Palitan natin ng ibang color. Ito naman, 29, no, not this, sorry, ito. This is supposedly, yan, 3, 30, 3, 31, 9, and 6. Is it also equal to 50? 50 din siya. Okay, because this is 35 plus 15 is also equal to 50. Okay, anything more? Now, if you check diagonally also, ito. I want you to pay attention to the sum of the following. Ito, let's make a diagonal. Or a diamond. Okay, diamond. Okay, 5 plus 8 plus, yan, 5 plus 8 plus 3 plus 31 plus 5. Okay? Ito, 5 plus 8, 13. Correct? Is it 50? No, I think it's something is wrong. How about ito? This with this? Hindi. How about this with this? Ito. Okay? Is it 50? No, it's no longer 50 but 52. Just the sum horizontally, vertically, and diagonally are equal to 50. Okay? Do you know of a technique of coming up with your own 4 by 4 square? Magic square. Now, that is a technique to coming up with your own 4 by 4 beginning with any number. 4 by 4 square, or I'm sorry, having any sum, I should say any sum. So I could say, or I could ask you to come up with a 4 by 4 magic square whose sum of numbers vertically, horizontally, diagonally would be equal to 45. Sige, tingnan natin yan. Okay? So, sum vertically, horizontally, diagonally would be equal to 45. Paano kaya yun? So, let's construct our 4 by 4 grid muna. 2, 4, 6, 8. Okay, so let's construct our 4 by 4 grid. 2, 4, 6, 8. There is a technique to this. Okay, you have to remember some numbers. Okay, so for instance, the last two cells along the first column should be occupied by the number 54. Okay, multiples of 9. 54. Okay, 54 dyan, tandaan nyo lang yan. The second row, 1, 8. Okay, so 18 is another multiple of 9. And then the third row, this time, alternate siya. Okay, the first column, 5, 4. Put that in mind. Second column, first two cells, 1, 8. Third column, last two cells should be occupied by 36. And last column, first two cells should be occupied by 72. Okay, so put that in mind. First column, 5, 4. Second column, 1, 8. Third column, 3, 6. And then last column, okay, first two cells, 72. Okay, and then here, 9. And then move, okay, 9 and then, bakit nang nangyari kay 9 ko? 9, move in a zigzag position, parang kanina, but this is empty. So, I'll have to write here 10, okay, and then 11, and then 12. 11, and then 12. So, yan yung mga tatandaan nyo. Again, okay, 54, ito yung tandaan nyo, okay? Along the first column, the last two cells should be occupied by 54, 5, 4. Okay, second column, the first two cells should be occupied by 1, 8. Third column, the last two cells, 3, 6. Okay, and last column, first two cells, 72. And then, the last cell along the last column, 9. And then, 10, 11, and 12. So, how many numbers are missing? 4 numbers. Okay? Let's label the missing numbers as A, B, C, and D. Now, suppose I'd like you to come up with a 4x4 magic square whose sum of the numbers diagonally, vertically, horizontally is equal to 45. There is a technique to find the number A. Okay, see A is simply obtained by, okay, A is equal to sum, okay, the sum given, which is 45 minus 20. Okay, so subtract 20 from the desired sum. So, yun yung rule kay A. Next, how about B? B is equal to A plus 1. Kung ano nakuha mo kay A, si C, ganun din. Okay? B plus 1. Okay. And then D is equal to, okay, subtract 1 from A. A minus 1. So, okay, ano yung instruction ko kanina? Come up with a magic square whose sum of numbers diagonally, horizontally, and vertically is equal to 45. So, ano si A? Anong answer kay A? What will A be? So, if we follow this, then 45 minus 20, at si A dapat ay 25. O, tingnan natin. So, erase natin si A, lagay natin 25. Tingnan nga natin kung 45 mamaya. Continue muna tayo bago natin i-check. So, si B, 25 plus 1. So, ano siya? No value ni B, 26. So, I'm going to erase this now. Okay, and I have to write here 26. Si C, ano siya? What will the value of C be? It would be, okay, so C will be 27. Okay, so C is 27. So, let's erase C. Gawin natin siyang 27. Okay? And finally, D is equal to 24. Okay, D here is equal to 24. So, D ay 24. Tama ba? O, sige, check natin. Get the sum of these numbers. Is it 45? Sige, is it 45? Okay, get the sum. This is 36. Okay, plus 9. Tama, 45. Next, 9 plus 36 is also 45. 12 plus, okay, 45. Okay, 45. Next, horizontally. Okay, 45 This is also equal to 45. The sum here is also 45. And then 45. Okay, how about diagonally? Check natin. The sum. This is 31. 31 plus 14. Okay, is also equal to 45. Okay, ganun lang siya kasimple. So, parang nagmamagic kayo. Huwag yung sabihin yung sikreto. Okay? So, how about if I say a sum of 50? So, a sum of 50, sige, gawin natin. Okay, come up with your own 4x4 magic square whose sum of the numbers, okay, horizontally 2, 4, 6, 8, okay, horizontally, vertically, and diagonally be equal to 50. Sige, gawin natin para hindi nyo makalimutan. What did I say? The first column should be, okay, occupied by the number 5, 4, 1, 8, 3, 6, 7, 2, 9, 10, 11, 12. Okay? What I want is a sum of 50. Okay? So if the sum is 50, what will be A value? What is A? Okay? Sum 50 minus 20, what will it be? 30. So, what will I write here? 30. Next, how about B? A plus 1. A plus 1. So, 31. Correct? So, B dito, 31. How about C? B plus 1. So, 32. Okay, 32. And D. What will D be? A minus 1. So, D is equal to 29. Okay, so 29. Check natin. 30 plus 11, 30 plus 11 plus 5 plus 4, what is it equal to? This is equal to, okay, 50. Next, is this 50 also? Is the sum of the numbers 1, 8, 10, 31, 50 also? Yes, 50. Okay, tama? B, 29. Oh, you're right. So, you're giving me the, okay, answers to, or should I say values of A, B, C, and D. So, 50 din siya. How about diagonally? Okay, 4 plus 10, 14 plus, okay, this is also equal to 50. Okay, so that's how simple it is. 50 lahat ng total nila. Okay, so that's the technique in coming up with a 4x4 magic square, okay, whose sum is, okay, indicated, o bahala na kung anong required na sum. Okay, so that's for the magic square. So this we have to give credit to the Chinese people. We move on to the next. Okay, some other significant contributions of the Chinese in the field of mathematics are the following. They developed the dualistic theory of yin and yang. Okay, yin represents even numbers and yang represents odd numbers. Yin for even and yang for odd numbers. They also discovered the concept of zero and invented a wide variety of mechanical aids, okay, like counting boards, and wrote numerous mathematical texts to aid them in mathematical calculation. Okay, you might say, because of the word counting board, that may have reminded you of the abacus. Okay, sila ba talaga ang naunang naka-invento or nakagamit ng abacus? Find out. Okay, do we really have to give credit to the Chinese people for the invention of the abacus? Okay, please read something about the abacus and you'll find out that it's not really the Chinese. Now, by the 4th century BC, counting boards were used for calculating, okay, which effectively meant that a decimal place value was in use. Okay, counting boards were uniquely Chinese. Next, the oldest existing Chinese texts containing formal mathematical theories produced during the Han period that contained various modern mathematical principles such as working with fractions using a common denominator, proofs of many geometrical theories, accurate process of finding out square root of numbers are contained in the following texts. Okay, the arithmetic classic of the Nomon and the circular paths of heaven, or the Chao Pei Suan Ching. Next. Okay, the most famous Chinese math book of all time is the Zhuang Xuanzhu, or the 9 chapters. Okay, the 9 chapters on the mathematical art, which contains contributions to mathematics which have been made over a quite long period. And they introduce the Chinese remainder theorem, integer, or list. Okay, list, integer, which leaves a remainder. Can you identify by guess and check? Remainder of 1, 3, 1, 0 rather. Sige, 1, 2 na lang. 1, 2, and 3 upon division by 3, by 4, and by 7. Ano kaya yung number na yun? The smallest number na kapag dinivide ko by 1, ang remainder niya 1. Pag dinivide ko rin yung the same number by 4, ang remainder niya 2. And when I divide that number by 3, ang remainder din niya ay, by 7 rather, if I divide that number by 7, the remainder is 3. Can you identify that? By guess and check. Okay, guess and check lang. Kasi I'm sure not all of you are familiar with the Chinese remainder theorem. But with the Chinese remainder theorem, it's an easy way of finding what number is it. Okay? What number are we referring to? Sige nga, can you guess? Ano yung smallest number na kapag dinivide ko by 1 or by 3, ang remainder niya 1. Pag dinivide ko by 4, ang remainder niya 2. Pag dinivide ko by 7, ang remainder niya 3. Can you guess what that number is? Ano kaya? Okay, 10. Okay, J. Mark said 10. He's right. Diba? Let's see. 10 divided by 3 is equal to 3 remainder 1. Yes? Okay, 10 divided by 4 is equal to 2 remainder 2. And 10 divided by 7 is equal to 1 remainder 3. Okay, 1 remainder 3. So, 10. Pag ang question naman can you identify that number which leaves a remainder of remainder of 1 upon division by 5? Jot it down. Sige, paano pag ganito yung question? A number, the smallest number, which when divided by 5, leaves a remainder of 1. Okay, remainder. Okay, remainder of 1 upon division by 5. 2 upon division by 6, and 3 upon division by 7. Sige nga, yan nga. Okay. Okay, number, the smallest number, smallest, take note, we are looking for the smallest integer that leaves a remainder of 1 upon division by 5, remainder of 2 upon division by 6, and 3 upon division by 7. No kaya yung number na yun? Can you identify what that number is? Anyone? I'll wait for your answers. Sige. Ano kaya yung number na yan? The answer is, it's quite big. 16. No, it should be isang number lang. It's a number. One number. Kung 16 divided by, look, 16 divided by 5 is 3, remainder 1. 16 divided by 6 is equal to, 16 divided by 6 is 2, remainder 4. Diba? 6 times 2 is 12. And 16 minus 12. So, hindi niya na-satisfy ito. This is not satisfied. Remember, it should give a remainder of 2 upon division by 6. So, hindi. So, ito, hindi niya na-satisfy. Okay, so, cross this out. It's not 16. Okay, any other guesses? So, hindi siya 16. And when we divide 16, okay, look, even when we divide 16 by 7, 16 divided by 7, okay, is remainder 3 and remainder 2 eh. Okay? It's 2, remainder 2. So, hindi na-satisfy ito. 56. Sige, check natin si 56. So, let's see whose answer is correct. Guess and check muna tayo bago ko introduce yung Chinese remainder theorem sa inyo. Okay, so, is it 56? Satisfied yung una. Okay? Pangalawa, satisfied. Pero, is the third satisfied? 56 divided by 7, does it leave a remainder of 3? No. Okay, no. Si 26. 26 divided by 5, okay, remainder 1, tama. Okay, remainder 1, tama. But, 26 divided by, okay, 6 is, okay, remainder 2, tama naman. Okay, satisfied. Pero, 20, no. 26 divided by 7 is, hindi. Okay? Hindi na satisfy ito. Okay, 7 times 3 is 21, so remainder of 5. If this should be remainder 5, then 26 is correct. But no, 26 divided by 7 is 3, remainder 5. Ito, remainder of 3. So, tama ba si 26? Tama ba si 26? 91. Check natin si 91. Sige, 91 divided by 5. Okay, obviously, remainder 1. Okay, 90 divided by 6. No, 1. It's 1, remainder 1, anak. Kasi 90 is a multiple of 6, yes? 60 at saka 5 at 30. 1 lang ang remainder. So, this is not satisfied. If it's 91, it does not satisfy the condition also. The remainder must be 2 upon division by 6. Okay, so, wala. So, this is where your Chinese remainder theorem would come in. Because it would be difficult to be just guessing and checking. Remember how many numbers have you given me? And now, none of them satisfied the condition. So, ano ba yung Chinese remainder theorem? The Chinese remainder theorem is used to solve a set of congruent equations with one variable. Saglit. But different moduli. These are the moduli. Single its modulus, which are relatively prime as shown below. Now, you will discuss more of this when you get to number theory. Are you familiar with modulo arithmetic, your clock arithmetic? Isn't it that when we reach 13th hour, we get back to 1? Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then back to 1, 2, 3, 4, 5, 6, 7, 8, 9. Yun yung modulo arithmetic. By modulo arithmetic, we mean, okay, let me discuss first so that you will know what to do. Your modulo, okay, set of modulo. Okay. Modulo arithmetic. When we say z sub 3, we mean the set of remainders upon division by 3. This is the modulus na sinasabi. So, sa clock arithmetic, ang modulus natin ay 12. Kasi when we reach the 13th hour, that goes back to 1. Okay? So, for z sub 3, we mean the set of remainders upon division by 3. So, ano yung mga remainders kaya when we divide a number by 3? So, the remainders are, when we divide a number by 3, we have 0, 1, and 2. Diba? 0, 1, and 2. Should we include 3? Hindi. Okay, because 3 is divisible by 3. So, that means the remainder must be 0. So, there is no such thing as 4 in modulus 3. Okay, because when you speak of modulus, okay, or the set of modulo m, set of integers modulo m, set of integers modulo m, we mean set of remainders upon division by m. Okay? So what is 9 modulo 5? Sige nga. What is 9 modulo 5? I'm waiting for your answers. What is 9 modulo 5? Again, when we speak of modulo, we mean remainder upon division by this number. Sige nga, anong sagot nyo? 9 modulo 5 is? Wala pa? What is the remainder when we divide 9 by 5? Answer is? Sige, sagutan ko muna yung una. Para yung susunod, alam nyo, is equal to 4. The remainder when we divide 9 by 5 is 4. So, 9 modulo 5 is equal to 4. How about 7 modulo 3? What is 7 modulo 3? What is 7 modulo 3? Remainder, sigurado kayo? 7 modulo 3, ang remainder 4, so you did not divide. Diba 7 divided by 3 is 2, correct? 2 times 3, 6. Ano yung naiwan? 4 o 1? 4 or 1? 1. Remainder. Remember? Bakit 4? Meron pa siyang sobra. Okay? Ang divisor natin ay 3. So, 1. How about yan. What about this? 11 plus 5 modulo 7. What about 11 plus 5 modulo 7? I'm waiting for answers. 11 plus 5 modulo 7 is late daw na send yung sagot nila. Anyway, tama naman. Okay, 11 plus 5 is 1, 2, 3. Okay, 2. So, yun yung konsepto ng modulo. Ano? Put this in your mind. Remainder upon division by the modulus. Okay? So, going back. So, if I ask you to identify the members of the set Z sub 5. Okay, Z sub 5. Ano yung mga members ng Z sub 5? Z sub 5. Ano yung mga posibleng 2 or 3? Members ng Z sub 5, we have 0, 1, 2, 3, up to 4. Okay? So, ano to? Can you answer this? Okay, the first is 1. Bakit 1? Okay, 2 times 3 is 6. 6 modulo 5 is 1. You're right. How about the second? Okay, the answer is 2. How about the third? 3 times 4 modulo 5 is also equal to 2. Next, 4 plus 4 modulo 5 is correct, 3. And finally, 4 times 4 modulo 5 is is 1. Okay. So, some of you got the right answer. I saw Christine's answer, Erica's answer, Angela's answer, all correct. And the rest also. As Cheryl also got the right answers. Okay? Okay. So, now you understand what modulo means. Okay. Ano namang kinalaman ni modulo? Okay? Ni modulo dun sa Chinese remainder theorem. In the Chinese remainder theorem, we will come up with a set of linear congruences. Okay, linear congruences. In fact, this is not supposed to be equal but congruent to. Okay? This is an example of a linear congruence. X is congruent to 3, let's say, modulo 5. Okay, 3 modulo 5. And like your linear equations, 2x is congruent to 3 modulo 5. Okay. So, for example, solve for x. Okay? Solve for x. Sige nga, trial and error muna tayo. Now, I want you to identify that x value which when multiplied to 2 times that x value will give a remainder of 3 also. Okay? Okay? Will give a remainder of 3 upon division by 5. What is x? Can you guess what x is? Can you guess what this number is? If this should have been a linear equation, it's easy to solve for x. Kapag ang given ay 2x is equal to 3, simply divide both sides by 2, yes? If it's an equation, okay? So, cancel this out, x is equal to 3 over 2. However, this is not an equation. It's a linear congruence. Okay? It's a linear It's a linear congruence. Okay, some of you answered 9. Sige, tingnan na natin. Ay, 4. 2 times 4 is 8. Tama. X is equal to 4. X is equal to 4. But how do we solve a linear congruence? This is by guessing and checking. Yes? Now, we can make use of the properties of Z sub M, okay, to solve for X. Okay, our target is to remove this or eliminate 2. Let me copy. Dito na lang sa baba. 2x is congruent to 3 modulo 5. Okay? So, our target is to eliminate this. Tanggalin. Tanggalin natin si 2 para x lang ang maiwan. So, let me write it first. Pero, wala namang division modulo M. Hindi pwede yung proseso na divide both sides by 2. But what we can do is, we find a number which when multiplied to 2, gives 1 as the product. So, what should this number be? I'll put a blank here, and a blank here, and I'll just copy the given. 2x is congruent to 3 times this number modulo 5. Now ask yourself, what shall I multiply to 2? Okay, take note that we are restricted to these values of x. Ito lang ang mga values natin because our modulus is 5. Okay, no number beyond 4. Because again, when we speak of modulus, remainders. So, si 0, 1, 2, 3, 4. Pwede ba si 1? Pwede ba si 1 dito? Can I have 1 here? No. Because 1 times 2 will be 2. Wala. It did not change the given. Can I also have, or can I write 2? 2 times 2, 4. Hindi naman siya naging 1. So, hindi rin. Okay, so I will erase this. So, we're done with, tapos na tayo na nag-check. Tapos kay 0, hindi pwede kasi magiging 0. Yan, nawala na si x. Pwede ba si 1? Hindi, kasi 2 pa rin. Pwede ba si 2? Hindi, kasi naging 4. Next, pwede ba si 3? Sige, sulat natin si 3. 3 times 2, modulo 5. What is 3 times 2 modulo 5? 3 times 2 is 6, correct? But 6 modulo 5 is 1. So, naging 1x siya. Okay, I hope you can follow. Is congruent to 3 times, ano yung minultiply natin sa left side? It's 3. Okay? However, 3 times 3 is 9, correct? But 9 modulo 5, 9, sige, sulat muna natin para you can follow. 9 modulo 5. But this is not simplified yet. Okay, because 9 modulo 5 is 4. Okay, 4 modulo 5. Did we answer the problem? Yes, x is equal to 4. So, tama si unang nagbigay ng answer kanina ay si Jacinto. Okay, correct answer is 4. So, what value of x satisfies this congruence? 4. 2 times 4 is 8, and 8 modulo 5 is 3. Okay? Can you try with this? Paano naman kapag ang given ay 3x is congruent to 2 modulo 5? Okay? Find x. Can you find x? Angel, 9 is correct, but you have to reduce it, anak. Okay? Kaysalyn, 9 is correct, but you have to reduce it in modulo 5. It should be 4. Okay? So, those who answered 9, Kaysalyn, Mary Joy, and Angel. It should be 4. Can you try with this? 3x is congruent to 2 modulo 5. Let me write on this side para may space tayo. Remember, we're talking of z sub 5, whose elements are 0, 1, 2, 3, and 4. And our congruence is 3x is congruent to 2 modulo 5. Okay? Solve for x. Okay, dapat alam nyo muna ito before we proceed to the next, or should I say to the remainder theorem. So just the same, sige, sagutan na lang natin. 3x is congruent to 2, let me put a space, mod 5. Just like what we did a while ago, we identify a number to be multiplied on both sides such that 3x becomes x only. Okay? So that's our target. Maging 1x lang siya, or x. So even without writing this, it's implied to be 1. Okay. Can it be 0? No. Can it be 1? No. Can it be 2? Yes. Okay. Can it be 2? Yes. In fact, this number should be 2. Because 2 times 3 is 6. But 6 modulo 5 is 1. So, 1x. So, what should this number be? 2 din siya. 2 times 2 is 4 modulo 5. Okay? So, who answered it correctly? Most of you. Very good. Okay? So, those who were able to send their responses were Jacinto, Jamaica, Jazel Ann, Christine, Angela. Okay, all correct. So are there questions here? One last before we proceed to the Chinese remainder theorem. Solve for x if the given is 5x is congruent to 1 modulo 5. So bakit 5x? Sorry, let me change it. 3x tayo. Ay, bakit 3x, 4x? Mali. Christine and J. Mark said 4. Sige, let's answer together. Okay, just the same, look for that number which when multiplied to 4x will reduce this into x alone. Okay, so what should this be? So that when we multiply it with 4x will give x only. Congruent to 1 modulo 5. Okay, what should this number be? Kung 1, edi 1 times 4, meron pa rin 4. Kung 2, 2 times 4 will be 8 modulo 5, 3. Hindi. Kung 3, 3 times 4, that's 12 modulo 5, 2. So, we're left with 4. If this is 4, 4 times 4 is 16. And 16 modulo 5, tama, is 1. Congruent to, okay, this is 4. 4 modulo 5. Okay? Tama ba? Okay. 4 times 4, checking. 4 times 4 is 16. 16 is congruent to 1 modulo 5. So, alam nyo yan, ano? Kaya kung ganito, sige, wag modulo 5. Paano kapag modulo 7 naman? 2x is congruent to 3 modulo 7. So, pag modulo 7, ano yung mga elements ng z sub 7? The elements of z sub 7 are 0, 1, 2, 3, 4, 5, and 6. Sige nga, can you answer this? What shall I multiply to 2 to get 1 as the product in modulo 7? Okay? What should be multiplied to 2 to get 1? as the product in modulo 7. So, let's check natin isa-isa. 2 times 1, hindi pwede. 2 times 2, hindi pwede. 4. 2 times 3, 6, hindi pwede. 2 times 4. What's 2 times 4? 2 times 4 is 8. Yes? 2 times 4, 8. Kaya 4. So, 4 dyan at 4 din dito. Times 2x is congruent to 3 times 4. Okay, modulo 7. Bakit 4? 4 times 2 is equal to 8, but 8 modulo 7 is 1x. Okay, but you don't have to write it. Equal to, okay, 3 times 4 is 12. However, 12 modulo 7 is 5. Okay, 5 modulo 7. So, the following got the correct answers. Jamaica, Christine, Melissa, Mary Joy, Joselle, Marilyn, and Flor Delin. Okay, very good. Other questions at this point? Okay, so X, and then I think those who answered 4, that's the answer to the question, what number shall I multiply to 2 to get 1? Okay, you're right, 4, because 4 times 2 is 8, and 8 modulo 7 is 1. So I think we are ready for the Chinese remainder theorem. So let's get back to our slide presentation. So you will end up with a system. So ngayon, hindi lang siya iisa, kundi marami, kaya system. Just like your systems of linear equations. Okay? So, for example, okay, this is a set of equations with different moduli, congruences. X is congruent to 2 modulo 3, x is congruent to 3 modulo 5, x is congruent to 2 modulo 7. Okay, translate this into word. Okay, this means find the least integer, find the smallest integer that leaves a remainder of 2, 3, and 2 upon division by 3, 5, and 7 respectively. Okay, so when translated into, when that word problem is translated into linear congruences, then you'll have this. X is congruent to 2 modulo 3, x is congruent to 3 modulo 5, and x is congruent to 2 modulo 7. Ulit, find the least integer that leaves a remainder of 2, 3, 2, upon division by 3, by 5, by 7, respectively. Paano natin sasagutin yan? Okay, may answer na ba? Okay, so may sagot, 23. The solution to this set of equations is, okay, 23. Tama ba? Sige, check natin. 23, mode 3. Okay, 23, tama naman. Because 23 divided by 3 is 7, remainder 2. Tama, remainder 2. 23 divided by 5 is 4, remainder 3. And 23 divided by 7 is, okay, 3, remainder 2. Tama. The smallest number that satisfies, okay, that satisfies that set of linear congruences is 23. But how? Okay, how is 23 obtained? So other than guess and check, there is a system of finding that smallest integer. And that's using the Chinese remainder theorem. So your Chinese remainder theorem employs 3 steps. Okay, let's look into the different steps. Okay, step number 1. Okay, find the M or the common modulus. Capital letter M is simply the product of all the moduli. Okay, so let's go back. Ano yung mga moduli natin? These are our moduli. Okay, so the first, we label that as small letter m sub 1. The second is small letter m sub 2. And the third is our small letter m sub 3. Okay? These are our A values. A values. A sub 1, A sub 2, A sub 3. Let's copy this sa scratch paper natin, dun sa solutions natin. X, okay, let me first write down the system given. X is congruent to 2 mod, ano yung given natin? 2 modulo 3, modulo 3, X is congruent to 3 modulo 5, X is congruent to 2 modulo 7. Okay? So, anong hinahanap natin? The least integer that gives a remainder of 2, 3, 2 upon division by the numbers 3, 5, 7 respectively. So, step number 1, okay, step 1, identify A sub i's, M sub i's, and M. The common modulus. The common modulus, or A's muna. A sub 1 is 2. Saan galing yung 2 ito? Okay? Please pay attention. Next, A sub 2 is equal to 3. Saan galing yan? Ito. Next, A sub 3 is equal to 2. This. Next, MI's. M sub 1, M sub 1 is equal to ito. Okay? 3. M sub 2 is equal to 5. And M sub 3 is equal to 7. Next, the common modulus M. Capital letter M. So I'm using capital letter M now. M1 times M2 times M3. Okay, what will this be? Okay, 3 times 5 times 7. So your capital letter M is 15 times 7 is 105. Okay, so we have now our modulus A sub i's and M sub i's. Now, aside from this, we will look into M sub 1, which is equal to M over small letter m sub 1, m sub 2, which is equal to m over m sub 2, m sub 3, which is equal to m capital over small letter m sub 3. Or simply, this is equal to m2 times m3. Pareho lang. Disregard mo lang si m1. Ito naman, m1 times m3. Tapos ito naman, m1 times m2. Pareho lang yan. So, m2 times m3 is ito. Okay? 5 times 7, what is it equal to? Let's use color blue. 35, m1 and m3 is 21. And M1, M2 is 15. Okay, so we are ready for step number 2. Other questions, step number 1? Do you have questions on step number 1? AI's, where did you get the AI's? This entries here. M sub i's, this number is here, the moduli. And then capital M, the product of the 3. And then capital M sub 1. That's disregarding the small m sub 1, m2, disregarding m sub 2, and m sub 3, that's disregarding m sub 3, small m sub 3. Okay, so step number 2. Okay, let's proceed to step number 2. Set up the following. Solve for x. Solve for m1, x1, is congruent to 1 modulo m1. Okay? m2 x sub 2 is congruent to 1 modulo m sub 2. Okay? M sub 3, x sub 3 is congruent to 1 modulo m sub 3. Okay? So this will give, what is our M1? Yun si 35. Okay? So magiging 35 x sub 1 is congruent to 1 modulo M1 which is K3. Okay, sagutin natin yan mamaya. Okay? Ito magiging M2 si 21. 21 x sub 2 is congruent to 1 modulo 5. And finally, 15 x sub 3 is congruent to 1 modulo 7. Okay? What are we to do? Sagutan natin itong tatlo. Okay, so let's copy. Okay? So 35, copy na lang natin dito. 35 x sub 1 is congruent to 1 modulo 3. 21 x sub 2 1 modulo 5 and 15, is it 15? Okay, x sub 3 is congruent to 1 modulo 7. Okay, so let's answer one by one. We begin with letter A. So ito muna. 35 x sub 1 is congruent to 1 modulo 3. Okay, what is 35 modulo 3? 35 modulo 3 is 2, right? 35 modulo 3 kasi 33 is the closest multiple of 3 to 35. So 35 minus 33 is 2. X sub 1 is congruent to 1 modulo 3. So parang yung ginawa natin kanina, we have to make this into x sub 1 only. Okay, so what shall I multiply to 2? Remember, modulo 3 ito. So, ang option nyo lang ay 0, 1, and 2. 1 di pwede because 2 times 1 will be 2. So, the only option left for us is 2. 2 times 2, correct, 4. 4 modulo 3 is 1. So, 2. So, ito should be multiplied to 2. Okay? So, 2x times 1 times 2 modulo 3. Bakit 2? Because 2 times 2 is 4 and 4 modulo 3 is 1. Kaya, this will be reduced to x sub 1 only. Is congruent to 2 modulo 3. Okay, so may x sub 1 na tayo. So here, x sub 1 equal to 2. Next, yung pangalawa, 21 x sub 2 is congruent to 1 modulo 5. Okay, reduce 21 to in modulo 5. 21 modulo 5 is 1, correct? So x sub 2 is congruent to 1 modulo 5. So itong pinakasimple. X sub 2 equal to 1. Next, 15 x sub 3 is congruent to 1 modulo 7. Okay? Okay, again, reduce 15 in modulo 7 is 15 minus 14, di ba? So, 1. So, x sub 3 is also congruent to 1 modulo 7. Are there questions at this point? Okay, 1. So, you said it correctly. So, x sub 3 is equal to 1. So, step number 3, last, final step, 1, 2, 3, we now compute for x. X is equal to, or congruent to rather, a sub 1, x sub 1, m sub 1, sorry. Let's go back to our, let's see if we have it here. Okay, nandito na siya. Okay, sige. Pero hindi masyadong klaro, kaya let's make it, or let's have the solution reflected here, plus a sub 2, x sub 2, m sub 2, plus a sub 3, x sub 3, m sub 3, all modulo the common, okay, modulus, which is m. Okay, and then by substitution, you'll have here, what is a sub 1? Go back. A sub 1 natin, itong mga to. 2, a sub 1. Okay, a sub 2, 3, a sub 3, 2, and these are the m's. So, ito, kailangan natin these values, and the x values that we have solved. Okay, so a sub 1, okay, going back, a sub 1 now is equal to 2, okay, 2 times x sub 1, 2, times m sub 1. Ano yung m sub 1 natin kanina? M sub 1 is 35, ito. Okay, m sub 2, m sub 3. So, times 35. Plus, a sub 2 kanina. Okay, a sub 2, let's go back. 3. Na siya. 3, a sub 2, m sub 2. 3, 21. Okay? 3, so I'll have it here written. 3 times x sub 2, ito, 1, times m sub 2, 21. Okay? Plus, a sub 3, m sub 3, go back. A sub 3, 2, m sub 3, 15, and x sub 3 ay 1. So, okay, 2 times 1 times 15. Modulo 105. Okay? So, let's simplify. 2 times 35, that's 70 times 2. 70 times 2, that's, wala na tayong space. Pwede bang dito na lang? X is congruent to, okay, 140 plus 21 times 3 is 63, correct? Plus 30. Okay? 30 all modulo 105. The space is not enough. Sige, liitan natin. Plus 30 modulo 105. Okay, get the sum. X is congruent to, okay, this is 170. So, this one is 203. So, 10, what will this be? Correct? 140, 63, and 30. This one is 233, correct? 233 modulo 105. Okay. So, finally, what is x? Okay? What is x? Ano yung remainder when we divide 233 by 105? So, let's divide. 233 divided by 105, that's 2, diba? Okay? Because this is 210, correct? And subtract, the remainder is 23. This is the remainder. So, let's go back. Okay, R is 23 modulo 105. And this is the answer. Okay, so the answer is 23. That's the smallest number That leaves a remainder of 2 upon division by 3. Okay, 3 upon division by 5, and 2 upon division by 7. Okay, did you understand the steps of the Chinese remainder theorem? So let's go back. Okay, go back. So what will be given is a set or a system of linear congruences. Identify your A values, A sub i's, M sub i's, compute for M, okay? And then set up your equations like this. Set up your congruences, M sub I, X sub I, M sub 1, X sub 1, congruent to 1, mod M1, okay? Depending upon how many linear congruences are given. Okay? So, from here, solve for x values, x sub 1, x sub 2, and x sub 3. And then step number 3, find the x value by setting up this congruence with the common modulus, which is capital letter M or 105. Can you try it with this example? Sige. Okay, so let's answer together, or would you like to try it on your own? Can you try this by yourself? Solve the system of linear congruence. X is congruent to 1 modulo 5, x is congruent to 2 modulo 6, and x is congruent to 3 modulo 7. Okay, let's do it until step number 1 muna. Step number 1 muna tayo. Step number 1, identifying the A values, M values. A sub 1, what is it equal to? So here your A sub 1 is 1, A sub 2, 2, A sub 3, 3. Your M sub 1 is 5, 6, 7. Okay, capital M is simply the product 5 times 6 times 7, and what is it equal to? M is equal to 30 times 7, that's 210. Next, solving for M1. M1 is simply M2 times M3. M2 is simply equal to M1, M3. And M3 is simply equal to M1 times M2. Okay, what will this be? M2, M3, 6 times 7 is equal to 42. Okay, and then 5 times 7 is equal to 35. Then here we have 5 times 6 is equal to 30. Okay? Correct. Capital M, Erica said, is equal to 200. Then step number 2. Okay, step number 2 is setting up our equations. The first will be M1, X1 is congruent to 1 modulo M1. Okay? Which is M1, 42. Okay, X sub 1 is congruent to 1 modulo 5. Okay. Next, M2, X sub 2 is congruent to 1 modulo m sub 2. So this will be 35. X sub 2 is congruent to 1 modulo 6. And finally, m3, x sub 3 is congruent to 1 modulo m sub 3, or 30, x sub 3 is congruent to 1 modulo 7. Okay, and then step number 3, or solve for x sub 1. So let's solve this. 42 modulo 5 is 2, okay, remainder kasi 42 yan. X sub 1 is congruent to 1 modulo 5. Okay, so anong i-multiply ko sa 2 para maging x sub 1 lang? Okay, para maging x sub 1 lang siya. Ano dapat ang i-multiply natin dito? Okay, anong number ang i-multiply natin sa 2? It should be 3, di ba? Modulo 5 tayo. So, 3 times 3 dyan, times 3 din dito. Okay, so 3 times 2x is congruent to 1 times 3 modulo 5. Bakit 3? 3 times 2 is 6. And 6 modulo 5 is 1. So, 3 modulo 5. So, I hope you can all follow. O, meron na tayong x sub 1 is 3. Next. Si 35 naman. 35 modulo 6. Modulo 6 f 5, di ba? So, 5 x sub 2 is congruent to 1 modulo 6. Okay, so 5. Ano yung multiply natin kay 5? Okay, 5x sub 2 is congruent to 1 modulo 6. Para maging 1 siya, ano dapat ito? Okay, what should this be? Okay, what should this be? Pwede ba ang 2? Hindi, 2 times 5, 10. Hindi. Pwede ba ang 3? 3 times 5, 15. 15 modulo 6 is 3. Hindi. Pwede ba ang 4? 4 times 5, 20. 20 modulo 6 is 2. Pwede ba ang 5? Remember, modulo 6 lang tayo. So, 5. Okay? 5 times 5, that's 25. Correct. So, 5 ito. Okay? So, ito din times 5. So, what will this become? X sub 2 now will be congruent to 5 modulo 6. So, x sub 2 is 5. Last. What is 30 modulo 7? Diba 28 ang pinakamalapit? So, 2. Diba? So, 2 x sub 3 is congruent to 1 modulo 7. Ulit, anong i-multiply natin sa modulo 7 tayo Okay, ano dapat ito? What should this number be? Para maging x sub 3 lang ito. Okay, 2 times 2, hindi po 2 times 5. 2 times 2, pwede ba? Hindi, 2 times 4, pwede ba? Yes, 2 times 4 is 8. Modulo 7 is 1. So, times 4. Okay, times 4. Okay, so x sub 3 is congruent to 4 mod 7. So, anong x sub 3 natin? X sub 3 is equal to 4. Okay, so we have x values, a values, m values. We are ready for the last step. Okay, so the last step na tayo, step number 3. Okay, step number 3, x now is congruent to a sub 1, x sub 1, m sub 1, plus a sub 2, x sub 2, m sub 2, plus a sub 3, x sub 3, m sub 3, all modulo m. Okay? X is congruent to a sub 1 is, let's go back to the previous page. Ito. Okay, ito yung a values natin. Okay? And these are our m values. So, a sub 1 is 1. Okay? 1 times 3 times 42 plus, okay? A sub 2 natin kanina is 2 times 5. Tama ba? Okay, tama. Ito. 3x values. Okay? 2 times 5 times, ano yung m natin na sunod? 35. Plus 3 times x sub 3 natin is 4. Tama? Times 4 times m sub 3 natin kanina is 30. Okay? All modulo 210. Okay, sige. Okay, x is equal to or congruent to 1 times 3 times 42. This is 126. Plus 3 times 5, 10. 350. Plus 3 times 4 times 30, 12 times 30, that's 360. Modulo 210. Okay, get the sum. So, bakit x bar? Sorry. X is congruent to, get the sum. 126, 350, 360 is equal to 63, okay, 836 modulo 210. Okay? Then, simplify. J. Mark answered 206 already. Kanina pa siya may answer actually. So, 836 divided by 210. Divide niya na lang. Okay? And then the remainder will be 206 modulo 210. So, the answer is 206. Okay, the answer is 206. Did you understand that? Medyo mahaba-haba, ano? Okay. So, it's 3:57 on my watch. Sorry, it took us time to discuss the Chinese remainder theorem. The rest, anyway, you can just go over on your own, can read. Okay, as fast as we could, let's just read. The Shuanshu, or the 9 chapters, is the oldest archaeological, mathematical text of the Chinese. The author is still unknown, and it made a huge contribution in the Eastern world. Most influential Chinese mathematical book, and it is composed of 246 problems, and it contains some theorems, theories in mathematics. And then the rest for Indian mathematics, you just read, look into the contributions, Hindu, Arabic. So our current number system, we have to give credit to the Indians. Okay? But it was communicated by the Arabs, kaya Hindu-Arabic numerals. Okay? Then, 0. The first to discover 0, although we made mention about the Mayans using 0 in their numerical system or the numeration system, but their symbol was a stylized shell, if you could remember, a stylized shell. But the first to make use of this symbol for 0 are the Indians. Called Bindu. Yan, okay? Placeholder and positional base notation, 10th place value. Aside from that, they also made contributions along permutations and combinations, roots of modern trigo, and infinity. Okay? And working with the positive and negative numbers Bhaskara. Okay? Yan. Divide any positive or negative number by 0, it becomes infinite. This is care of the Indian mathematicians. What else? One-to-one mapping. Okay? So these are some of the significant contributions, but we will discuss in detail some of the important contributions of famous Indian mathematicians in our next session. Are there questions at this point? So the rest you just go over, okay? Read the rest of the slides, but I'm giving out an assignment in relation to the topics that we have discussed this afternoon, particularly the contribution of the Chinese in terms of the Chinese remainder theorem and the magic square. I will upload your assignment right after our online class to Lens. Okay, you can access Lens and download the assignment. And you can submit, okay, either online or any file type is accepted. Are there questions at this point? How many got 206 by the way? Ang unang nakita ko nagsagot ng 206 si J. Mark. Kahit hindi pa tayo tapos sumagot kanina, may sagot na siya. Ito, okay? J. Mark. Joanne also, 836, modulo 10. Hindi lang niya na-continue. Daniel also, Erica, Juliet, Joybell. Although hindi kasi nila ni-reduce. But the correct answers were given by Joanne, Christine, Juliet, Angela, Erica, Flordeline, Christine, and Marilyn. Okay? So if there are questions, please raise your questions now. Otherwise, we call it a day and we will end the session.